Hello, Calculus fan. Somebody's asking about this center of mass question on the discussion board, so let's take a look at it. Again, this is the exam I handed out in class. I think they're asking about part B, but ultimately this says find the x-coordinate of the centroid. You may assume the y-coordinate is 0. In terms of drawing, you might say, well, I don't know what this looks like, but as x goes to infinity, you go to 0. So a quick glance tells us the picture looks like this. And they're saying we're going from 1 to A. Oh, I see. So they're mixing in an improper question. So I think they're going to ask in the next part, somebody's asking, what's the limit? What do they mean by what happens when A goes to infinity? What they mean is, what's the limit as A goes to infinity? That's just another way to say it. So you can take whatever you get in part A and then take the limit. But just briefly, this is a straight computation question. I've never done this before, so correct me if I've made any mistakes here. But ultimately, we have two things to do. X bar, just as a reminder, is the integral from A to B of x times top minus bottom. Divided by the area, which is top minus bottom. Now, the truth is, when you do the area, you could just do the top and then multiply times 2. But let's first maybe do the area. So we're going to do the integral from 1 to A. So this entire question is in terms of A. Then in part B, they're going to say what happens as A goes to infinity. But we'll leave that for later. Okay, so the top minus bottom is going to be 1 over x cubed minus negative 1 over x cubed. If you couldn't draw the picture and didn't know which one was on top and which one was on bottom, you could make a table. Just plug in 1 to both of them. First y, the second y. The first y being 1 over x to the third. Second y being negative 1 over x to the third. This is 1, this is negative 1. You could ask yourself, which number is bigger? This one gave me a bigger number. So you can even, if you were stuck, there's plenty of ways to get out of it. There's the integral from 1 to A of 2 over x to the third dx. And so it's going to be, that's a calculus student would write that 2x to the negative 3. So that's going to be 2x to the negative 2 divided by negative 2 from 1 to A. So it's going to be negative 1 over A squared. And I just from experience know that I'd much rather write this simplified rather than write A to the negative 2 minus negative 1. Okay, so the area, let's kind of do a little state of the problem. The area is... Let's write this as 1. How about we write it as 1 minus 1 over A squared. I was just cleaning that up. This is a plus. So if you don't understand what I just did, I just flipped the ordering of addition here so that it would look nicer. Okay, next one. So now we're going to throw in an x. Let's see what happens. So we're going to do the integral from 1 to A of x times this. Now we already know that that's just 2, so it's going to be 2x over x to the third. Because this already was f of x minus g of x. So that's going to be 2 times the integral from 1 to A, and now it's going to be x to the negative 2. And when we integrate, it's going to become 1 over negative 1 from 1 to A. So this isn't too bad. It's kind of nice. You get negative 2, 1 over A, minus negative 2. So this ends up being 2 minus 2 over A. Let's see if that's reasonable. Yep. This is going to be 2 minus 2 over A. In fact, it's already written in a way that taking the limit will be fairly quick, because this is going to be 2. I wouldn't want to rearrange it if I knew the goal was to figure out the limit. Because when you're going to infinity, you would much rather write things like this. Because you can quickly see this goes to 0 and this goes to 0, and the answer is 2 minus 0 over 1 minus 0, so it's 2. So here's a situation where you can balance that on your finger. It's 2. All right. Hope that sort of makes sense. Let me know if you have follow-up questions.